I was really excited to see the Tesla AI Twitter handle put out that thread a few weeks back. And I've just been thinking about this and trying to dig back through Dojo Tesla videos. And especially, there was a really great conversation that Gally actually hosted on Hyperchange with Naveen Rao, Dylan Patel, and then for those who were OG ARC followers, James Wang participated in that conversation as well. And it was a really good place to just get expectations set properly on Dojo and their competition with Nvidia. And it's fascinating to see what Tesla's plans are. That, as FSD continues to grow, we have a larger fleet now that's collecting more data, more miles. They're trying to do more and more training. Obviously, Optimus is also something that they're going to be doing a lot of training for. And potentially, it's hard to say what the compute needs will be for Optimus training versus Tesla bot training, versus FSD training. But 100 exaflops is a huge amount of compute. And if you kind of do the math there, they're assuming that in 2024, a 33-ish exaflop total amount of compute will be top 5 in the world. And that, within, what is that, 8 months from there, that they'll be at 100 exaflops. I mean, that's ridiculous amount of compute.
Can you help us quantify? Can you help us understand why in such a short period of time that's such a ridiculous jump? Maybe like contextualize it, or help give some.
Yeah. So I mean, the Dojo, when they talked about Dojo, one plane, they were saying was going to be 1 exaflop, and that's a lot. But they announced this back in 2021 at the Nvidia conference call that they just had. The new Grace, GX 200 something, their large data center, that's also going to be 1 exaflop. And that, there's a limited number of companies in the entire world that have that much compute. And so Tesla's trying to get up there to have that amount. We're talking about AWS level, Microsoft Azure cloud level compute infrastructure. And so they have, if they're trying to develop that much compute, that means they're trying to solve really, really hard problems. And the thing that I wanted to bring up from the graph is just how steep that ramp is. There's no way that they can buy that many, because in the graph here, they don't say that this is just Dojo only. And so it leaves a little bit of room for interpretation on, okay, so how much NVIDIA compute are they going to be buying versus how much Dojo compute are they going to be producing? There's no way that they'll be able to buy essentially, what would that be? 60 some odd of those large NVIDIA exapods in 10 months. Like, NVIDIA is not going to supply it. Like, this stuff is unobtainium. Everybody wants it. Everyone's willing to pay a premium for it. And so that means that has to be, at least half of that, if not more than half of that, is going to be Dojo, which also means that the software that they have written internally to be able to actually use large clusters of Dojo supercomputers all together in a seamless way. Because you've got, when you're trying to train a large neural net model, it's way bigger than will fit on any single computer, any single GPU. I mean, you're talking about a data center's worth of compute chugging away on a problem. And so you have to be able to get all of that problem divided up and distributed across tons and tons of individual pieces of compute, and then talking to each other fast enough so that they can do that in a time efficient way. And that software is as much of a challenge as the hardware infrastructure. So there's a stack of things that have to all work perfectly in order to do that, to advance artificial intelligence training, training large machine learning models. And the fact that they can do that in-house means that they have an internal equivalent to CUDA that is workable. Now, that doesn't mean that it's something that can be used as a training as a service product in the future. That's further down the road. But what it shows us is that they really are able to keep pace with NVIDIA. And that is an incredibly impressive feat because, there's a lot of things that go into just how impressive really the entire AI tech wave is really built on NVIDIA, their software and hardware stack. And Tesla's able to go basically head to head with them. Now, that doesn't mean that they're able to surpass them. It's a huge gamble. And Elon has said this himself. Dojo as a service may or may not pay off. If it does pay off, it would be absolutely huge. If not, at least we put our hat in the ring. But the learning that they're getting from doing that will be incredible either way. And I like the way that James Dauma has put this, that it's almost like just their hedge. We have ambitions that we want to grow our ability to be a world leader in artificial intelligence products by 2025, 2026, 2027. And if NVIDIA is not able to supply us with the necessary hardware and software in order for us to fulfill those ambitions, we want to have our own options also that have been co-developed and will be ready to go at that point in time. And so it's just exactly like batteries, essentially, that Tesla said, hey, we're going to build our own in-house batteries. We're going to produce tons of them. We want terawatt hours worth of battery production. Oh, and by the way, none of our suppliers need to be scared that we're going to stop buying Panasonic batteries and LG batteries and Samsung batteries. We actually want to buy as many batteries as all those other players can provide to us on top of all the ones that we build ourselves. They're doing that exact same playbook with compute. And all of this is building up to, right now we just saw GPT-4, Chat GPT and GPT-4 be released. And they're incredible because what we've found is that when you train up a large language model with enough parameters and you feed it enough data, that you get like exponential, just step change increases in functionality that you didn't expect from, it's kind of like a linear thing that's going up. And then all of a sudden it's like, just goes vertical in the amount of things that it can do. And surprising, like ChatGPT understands things at levels that you would never have expected in 2021 or 2022 even. But we don't have an analog for that for something that interacts in the real world. And what it looks to me like Tesla is aiming at is they're trying to train up a real world foundation model for how things move about in 3D space. And so I'm starting to refer to this as they're building meat space GPT. So they're trying to create a foundation model that understands how physical things interact in physical space, how not only just the physics of everything works, but how to model the behaviors and like make predictions on what live intelligent beings are going to do. And so the the degrees of freedom for that, just the number of possibilities is absolutely endless. And to solve this problem, like it's way harder to create meat space GPT than Chat GPT. And that's why they need this incredible, like this is way more compute than was ever needed for OpenAI to get from Microsoft to train up GPT-1, GPT-2, GPT-3, and GPT-4. And so that signals that what they're building is a a foundation model that's built on GPT, a generatively pre-trained transformer architecture, and that's what all the large language models are. They're built on these GPT constructs. They're using that now to take something that they can put in the car and allow FSD to work, but also it's what they're going to need for Optimus to be able to be a useful, intelligent agent that can reason and think and learn and do normal labor tasks. And, it's easy to just go straight to the Optimus bot as a person working in my house and doing my chores thought process. But the amount of useful things that can come out of whatever that foundation model is that the Optimus bot is built on, it's both, embodied and non-embodied things. Like there's an incredible amount of services, and I don't see anyone else who is attacking this problem in this way. That, OpenAI and a host of open source companies are trying to progress artificial intelligence in the idea space, but Tesla is trying to do the equivalent of ChatGPT in the real world, and that is just, it's incredible. So
let me throw out a couple of things, because I think I finally understand what this is meant to do long term, or what their goals are. Number one, I'll start with saying that Meat Space GPT should be your first merch item. So you should think about doing that for your YouTube channel. The second one is so pull up the chart again, producer wife, if you get a chance, on Twitter, of the Dojo line going exponentially. Is this directly correlated with Tesla FSD's performance, this rate of progress? Is that a good way of thinking about it?
So James Dalma has articulated this very clearly, that it's going to feel like linear, each extra 9 in the march of nines. So to get from 99.9% good to 99.99% good, well, that you reduce the amount of error you have in the system by 10 times. If you have 0.1% down to 0.01%, that's a 10x reduction in the error that you have. And you have to do that for each 9. And, if we want FSD to be something that has 0 interventions for, say 1,000,000 miles, that's the level that it takes to be significantly, 10x safer than a human. We're still a long way from that at this point in time. And so in order to keep getting adding 1/9 of performance to the safety of FSD every, say, year or 6 months or 3 months, you have to have an exponential increase in the capability of the system. Otherwise, it would take exponentially longer. So then you're, instead of, this time it takes a month, next time it takes 2 months, next time it takes 4 months, next time it takes 8 months. If we want the progress to continue to come at a linear pace that we feel, the technology, the compute has to drive up exponentially.
Got it. So going from 99% accuracy, or 99.9% reliability, to 99.99% reliability might take 5 exaflops. But to get from 99.9999 to 99.99999, or one more, you need 100 exaflops. And if you want that to happen within the same 4-month span of getting there, so even though the change is going to be basically, we're not going to perceive it because it's so small, that tiny little thing is so important to get this thing basically proved out for regulators and the public, that unless you do 100 exaflops or whatever that number is, it's not going to be done in a reasonable amount of time.
There's a couple different things that are all exponential, and so it's not only the hardware that has to be rising at an exponential rate, because our knowledge about how these transformers work is also growing. And so we've got a couple of different exponential
Mm.
curves that are kind of compounding together. So we don't have to, it's not, well, 1-to-1, that we have to have 100x more compute to get 100x reduction in the safety of the system. But it is, loosely, those are the correct shapes of the curves.
Got it. Alex, go ahead. I saw you coming off mute.
Yeah, the interesting one on that graph of the from Tesla AI is if you look at what they're training on now, they plan to double that every quarter for the next 5 quarters. So if you look at they're starting at about 10,000 or wherever they are now, and you look at next quarter and it's like double, and the quarter after that is double again, and the quarter after that is double again, and the quarter after that is double again. So they're looking over the next 5 quarters to double their compute every quarter, 100% rate of growth, not like the 50% rate of growth that they're trying to do on 150% per year. They're doing 100% per quarter on their compute as a target, which, will melt some analysts.
And eventually we will solve the FSD problem. And then you have this giant compute resource. And the question is, what do you turn that loose on? And this is where everyone goes. Obviously, the next big thing from here will be training the Optimus bot. And like I said, working on that foundation model that generalizes beyond FSD to also be something that the bot can operate on. But then you do get the idea that potentially this is a training as a service platform that can be used. It would require a dramatic culture shift for Tesla to think of themselves as a software as a service company and be willing to provide that ability to external customers that meets external customers' needs and demands, especially when, NVIDIA is also developing their platform at an exponential rate. And the benefit that NVIDIA has going for it is they have an entire community of developers around it, just like, the iOS App Store developer community is a huge part of the success of the Apple ecosystem. NVIDIA has the same thing going for them in artificial intelligence. And so, all of the breakthrough research is done on NVIDIA hardware. So it remains to be seen whether Tesla can offer something that is useful to the entire community in that way, even if, the hardware is potentially capable of that. But if they do, that is another huge market.
Richard, did you have anything? I have a couple more things I want to ask Hans. Did you have anything you wanted to add to the discussion? I don't want to.
Yeah. No, just that I saw that software as a service, that if it could be worth $1 trillion market cap, just that one division.
Okay. So let me ask a question here, Hans, as you're talking about this, letting it loose. So not just a Tesla thing, but a software as a service, and sort of the context that this could be used on. So and tell me if I'm thinking about this incorrectly. So does this mean that in the future, Tesla could, so when you say meet space GPT, which is a way to interpret the real world, right? So that we can have the ability to interpret the real world. Is this something like, I am a robot vacuum company, and I don't know about you guys, but my robot vacuum is okay, but it still doesn't know how to interpret the world perfectly. Does this mean that robot vacuum from 2030 or excavating machinery company from 2030 or 2035 can go to Tesla and be like, hey, I would love to use your Meet Space GPT framework to bolt on my, I don't know, camera system and control system, so my robot vacuum or my excavator can actually see what's going on, and then we'll layer on our, okay, do this with this, do that with that, right? Is that a proper way of thinking about this?
Yeah, that's exactly what I'm thinking about, because, right now we have these open source LLMs, and people are taking that foundation model and then they're doing specific types of ways to basically constrain the output of that to work in a certain context. And so what we're going to see here in the next 5 years is, there's going to be lawyer GPT and doctor GPT and all these things that are incredible. Sorry, Richard.
He's not
incredible at being able to provide value-added services to people that mimic or even potentially surpass what humans can provide in certain areas. That same type of foundation model, once there is a good physics model understanding of the world and a good model to actually predict behavior of intelligent, agents in your area, that is something that you can build on top of for all types of specific narrow use cases that can fulfill, a vertical. And so exactly like you can have your mining, your meat space mining GPT. You can have your meat space cleaning GPT. You can have your, you could just go on pretty much endlessly for a lot of value added physical labor type services that can all be built on top of that for any variety of, and once that thing exists, pretty much anything will be built on top of that type of architecture, like
in the physical space.
In the physical space, yeah.